friends, in this video we'll have a look at recursion. So this is one of the interesting and fascinating topics in programming, which helps you to visualize programming to the next level. But if you're not comfortable with this topic recursion, feel free to skip it. I have seen a lot of good programmers, excellent programmers writing excellent code without playing around with recursion, because the recursion sometimes cause trouble in a larger system. I'll tell where and why. Okay, let's go into that. Okay, the first warning is, like, if you don't understand, it doesn't mean it's bad. Like, you can skip it. Okay. So recursion is a technique where a function calls itself. That's all about recursion. Okay, and as I said, it is one of the effective techniques in the thing. Okay, let's go back to the normal way of calling. Like, let's assume I have a main, I have a square method. If this calls this is a normal thing which we do it. But in case of recursive method, a method calls itself, like factorial calls itself again. Okay, let's see some examples, then let's understand better. Before going into that, we have to recall two things. One is stacks and method and how these are related. So when main calls square, first main goes into the stack, first pushed into the stack, and then since it is calling square, square is pushed in on top of main. Assuming if square is calling a rectangle, the rectangle is pushed on top of square. And whenever the execution starts, it starts from rectangle, then square, then main, and then cleans up the stack. This is how it goes on. So I'll tell why this stack image is very important when we are talking about recursion little in the future slides. Okay, let's write the simplest form of recursion. Let's say the main calling itself main. This is the simplest form of recursion. Let's visualize that in the previous slide which we have it. Like, so the main will sit on top of main. It will be going on indefinitely. So what will happen, like how many number of times you call, there is always a finite number of amount of memory only is available for us for the stack. So obviously stack overflow will happen. Okay, so that's the reason why we asked to visualize that. Okay, so then how to go and solve about try solving a problem for recursion. First thing is, like, pick the bigger problem and try to put into smaller sub problems. Okay, and look into the sub problems and identify whether it is alike, it's the same kind of it. For example, if I want to travel from here to New York, okay, so I'll think through, why don't we go, we'll go from here to Delhi, not to New York. So I want to go by train. Okay, from here to Chennai Central I have to go, from Chennai to next station I have to go, from Chennai next to Bangalore. Let's assume I'm traveling to different paths in the waypoints and then traveling to Delhi. So all the sub problems are like traveling from one to another. So all the traveling problems looks alike. Okay, the problem can be solved either recursively or iteratively. Iteratively, when I say, it is a looping thing, for loop or while loop. When I say recursively, this is the way. So if the sub problems look same as the bigger problem, and then that problem can be taken for a recursive solution, you can try out. Okay, so let's see some of the problem. Okay, before going into that, like, so I am splitting the sub problem, right? Somewhere the sub problem has to stop. Okay, so where to stop is called the base case. If you don't write the base case, your stack will overflow and your program will crash. This is the reason why I warned you in the earlier, like, if you are not interested or if you are not fascinated by recursion, please skip it rather than crashing the entire code. Okay, and always remember, you have to make progress by solving the sub problems. Okay, so let's fix the problem which we have written already. So I used a program like main calling main. So what I have done is, like, I have declared a static variable. Static variable lives till the program ends, and then I increment one by one. Okay, and I increment and check. This thing is called the base case. Somewhere when it comes to 10, I stop calling the main again. Okay, always try to find out the base case first. Without the base case, there is no recursive solution. Okay, so let's take another meaningful example. This is a meaningless example what we saw. So we want to arrange all the bookshelves, all the books in a bookshelf in one attempt. Okay, how to solve it? A single person cannot do it. So what we do is we ask a single person to arrange one book. Okay, so one book or one row or one rack, like that we solve it, and the arrangement at the end of the day might be solved in a better way. Okay, so this is another candidate for recursion. Okay, this is the thing. For example, arrange. When the number of books is 1, I stop the arrangement and I start putting the book into shelf. Till that, I start arranging all the stuff. That's it. So this is a recursive way of thinking. As simple as that. Okay. So this is another problem where sum of natural numbers using recursion. Okay. Where I go till the number is 0. Okay. So if the number is 0, till that I add. If the number is 0, I stop adding. Sorry, stop calling recursively and start adding stuff. Okay. Some of the other problems which you can solve recursively is like traversing through a directory or a file system. Okay. For example, C colon in data, another folder like that. If you are going, that is a recursive thing. And traversing through tree. For example, if you are traversing through a family tree, find a cousin. Okay, he is related to this, he is related to, or even in LinkedIn, or even in your Facebook, if you want to find a friend. Okay, that can be solved recursively. Okay, and sorting algorithms, lot of sorting algorithms like merge sort and other guys, quick sort, can be solved recursively. Okay, some of the basic interview problems which people will ask for in terms of recursion is raising a number to a power, factorials, anagrams. This is most popular problem which is asked in the recursion. And binary search, obviously binary search is can be solved pretty much recursively. To elaborate, like binary search, any divide and conquer problems can be mostly solved in recursively. If the when you divide and find the sub problems are same, you can go for recursive solution. And towers of Hanai, this is a famous solution, famous problem which you can solve it. Merge sort, I was saying about sort, right? Merge sort is another candidate for it. And most popular place where this recursive solutions is used as combinations, permutation combinations, you can use it. Okay, so now going to recursion versus iteration. As I was saying, recursion, anything which you can solve in recursion can be solved in uh, iteration. Okay, so if you're finding hard with recursion, go and solve with iterative solution. That's nothing wrong in that. It might be little expensive, but it's okay to do it. At times, it is not always expensive. At times, I'm saying a recursive algorithm using a branching structure, whereas the first guy uses a looping structure. Okay, so recursion finds a simpler and a shorter solution, and it can be understood by most of the people. Okay, and as I said, all the recursive solutions can be solved without recursion as well. And sometimes the recursive solutions are very expensive because every time you push into a stack, it is a costly operation. Creating activation record and pushing things, all those things is a costly affair. Okay, so it could be inefficient both in terms of time and space if you are doing applying the recursion for a wrong problem. Okay, but apart from that, like a lot of bigger problems, you can solve it in a few lines of code with the recursion. Okay, so that is the answer for it. Okay, thank you friends, bye bye.